Factoring expressions of the form ax squared plus bx plus c part 4. Okay, we have this example now. You may have noticed that I skipped examples 3 and 4. I skipped examples 3 and 4, but it's up to you to try them on your own as well. And if you have any problems, we'll take it up in class. Okay, let's look at this example now. Right. We have 10x to the power of 4 minus 3x squared minus 18. Alright, let's see if we can factor out a common factor among all of these terms. No. Is it a simple trinomial or a complex trinomial? It's a complex trinomial. You may be wondering, how come it says x4, x to the power of 4, and x squared here? This doesn't look anything like our usual, let me write it down here, our usual ax squared plus bx plus c. You may be wondering that. Okay, so often when we get these expressions, right, we have to pay close attention. Right? What's another way of rewriting this in this way? Right? See if you can figure this out. Well, we can rewrite this expression here, or we can view it in this manner. Right? 10x, and if you remember your exponent laws, which I'm sure you do, or you should remember it by now, 10x squared to the power of 2, which is actually x to the power of 4, right? Minus 3x squared to the power of, well, 1, right? Minus 18. Right? Okay. So in other words, you can let x, right? You can view this expression as though you were letting x equals x squared, right? Just like here, this could be x and this could be x. Okay, and then after that, it's the same as before, right? We're dealing with a complex trinomial here, so we're looking for two numbers, and I'm going to use a different sheet here, a separate sheet, simply because I noticed I run out of space. Alright, let me move this up a little bit so we can see. Yes, so we're looking, just like before, we're looking for two expressions, right? Two numbers that when multiplied will give us negative 180. Okay, so negative 180. And when we add these same numbers, we want to get negative 3. Okay, so let's find out what these two numbers are. I'm going to use this sheet as I said before, right? Use this sheet. Okay, so we have 180, right? This is the same as saying 18 times 10, which essentially here is the same as saying 5 times 2, and here is the same as what? 6 times 3, and then this 6 breaks into 3 times 2, right? Okay, so let's see if we can find a combination of numbers so that we can get negative 3. We know that the product will have to be negative, so let's put here negative, right? Okay, as a reminder, well, in fact, it's probably not a good idea since, you know, these numbers are positive, but you know essentially what I mean. So, let's find a combination that will give us negative 3. Okay, so what are these numbers? Well, we have 10. We have 3 times 3, 9, times 2, 18. We add those, no. What are these two numbers? What are these two numbers? Let's see. 3 times 2, 6, times 2, 12, and we have 15 here, 12 and 15. Yes, when we subtract them, we can get a negative 3, right? Now we know that the product will have to be negative. We know that the product will have to be negative, so that means both numbers will have to have a different sign. So yes, that would work. Actually, that would work. The 15 from these, and 3 times 2, 6, times 2, 12, right? So 12, right? And the 15. Now we need to get negative 3, so it's going to be negative 15 plus 12. Okay, so so let's go back to this. Now we know what our two numbers are, negative 15 and 12. So I'm not going to rewrite them as x squared to the power of 2 anymore, because it was basically a matter of visualizing that request. But now that we know what our two numbers are, let's start solving this. So we get 10x to the power of 4. Let's split up this middle term into negative 15x squared, right, plus 12x squared. Those were the two numbers that we got, and let's bring the negative 18. Those were the two numbers that we got, and we were using to split our middle term, right? Right, from the tree, these were the two numbers that we got, right? The negative 15 and the 12. Okay, so, and then essentially it's the same as before. Let's group the terms, right? So let's go slightly faster with this, right? So we have, what's common between these two expressions? Well, they're both multiples of 5. The constants, 10 and 15, are multiples of 5. And among the variables, the x squared. Alright, so let's open bracket. Here we have 5x squared times 2x squared in order to get 10x to the power of 4. Negative 3, so 5 times negative 3 in order to get negative 15, and that's it, right? The x squared stays the same. So and between these two we can factor out, well, 6, right? 6, and among the variables, well, not really, so that's it, only the constants. So 12 and 18, they're both multiples of 6. So this means that 6 times 2x squared in order to get 12x squared, and 6 times negative 3 in order to get 18. Alright, this is starting to look pretty good. Now between these two expressions, let's factor out a common term. Well, the common term is this binomial, so 2x squared minus 3. Let's factor that 2x squared minus 3 among these two expressions. So this times 5x squared to get this expression, and 2x squared minus 3 times positive 6 to get this expression. And that's it. So we're done factoring this. Right, you have example B with you. I want you to try it, and we'll take it up.